The human body is composed of 4 main components: water, fat, protein, and minerals. Having a moderate amount of each component is important for a healthy life, and the BIA is considered as one of the most practical methods to know. BIA, Bioelectrical Impedance Analysis. This method applies small currents throughout the body and measures the voltage to get a value called resistance, also known as impedance. The principle behind BIA is to flow electrical currents throughout the water in the body and to measure the amount of resistance the current encounters as it travels. Simply, more water will lead to lower impedance. For example, although the 2 men weigh the same, A has a higher amount of muscle mass than B. Since muscle cells hold more water than fat cells, electrical currents can more easily flow through A and will show a relatively smaller impedance value than B. And with this impedance data, the volume of a person's total body water is determined. So then, how did this technology come about? In 1969, an experiment was carried out to find the correlation between whole body impedance and volume of total body water. The study proved that the impedance index, height squared divided by impedance, had the highest correlation with total body water. This index is considered as the starting foundation of BIA devices. 10 years later, an American company commercialized the first impedance meter. This meter used a single frequency of 50 kHz and measured the body's impedance. Due to its simplicity and convenience, this BIA device sought attention from many researchers. However, as more researchers started using the device, they soon became skeptical of its accuracy. The device's claim to produce whole body results actually only tested the right half, and their use of a single low frequency inaccurately measured the whole body impedance. In order to compensate for its inaccuracy, scientists developed equations using empirical estimations such as age and gender. However, the equations were only specific to their test groups, and with so many additional factors to account for, no equations were applicable to all. After years of developing additional equations and incorporating empirical estimations, scholars concluded that technological improvements, rather than equations and estimations, were required to overcome its inaccuracy. BIA required technology that can provide segmental impedance and body water compartment measurements using a multi-frequency method. Then in 1996, the Inbody, a body composition analyzer that took into account the limitations of conventional BIA devices, was introduced. This technology included segmental measurement, use of multi-frequency analysis, and an 8-point electrode system. With these advancements and without the use of empirical estimations, the Inbody achieved 98% correlation with DEXA and an impressive reproducibility of 99%. Prior to these advancements, the conventional BIA method considered the human body as one cylinder and only offered a single whole body impedance value. However, since impedance is derived from factors such as length and area, different sizes would yield drastically different impedance values. At a closer look, our body is not one, but 5 cylinders with different lengths and widths, and therefore, measurements should be segmentally analyzed. Furthermore, when it comes to the trunk, its short and wide cylindrical shape yields a very low impedance value. The trunk only accounts for around 5% of the whole body impedance. Yet, it is responsible for about 50% of the whole body mass, indicating that even a small change of 1 to 2 ohms in the trunk impedance value can significantly alter the whole body lean mass. Whenever it comes to the use of multi-frequency, low frequencies tend to flow outside the cell membrane, while higher frequencies flow through both inside and outside. The use of a single low frequency is incapable of determining the water inside the cell. However, with the multi-frequency method, it is possible to accurately measure the total body water. More importantly, this method distinguishes and reveals the balance between intracellular and extracellular water. After incorporating segmental measurement and multi-frequencies, an 8-point tactile electrode system was also adapted to enhance and maintain the reproducibility of the results. More specifically, the use of separate thumb electrodes consistently fixed the starting position regardless of the way the electrodes were held. Today, with these technologies, high accuracy is achieved, and factors such as age or gender are no longer required. As a result, BIA is considered as proven technology and is being widely used for many medical and research purposes, from sports medicine to nutritional management and many more. This device's accuracy, simplicity, and convenience have been validated and published in numerous renowned medical journals and studies worldwide.